Howdy. Welcome to section 8.6, part B. Today is the end of chapter 8. It be the end of chapter 8. Again, 8.6 part B is what you're looking at. Closing out chapter 8. We'll be testing on this later on next week. And believe it or not, this will be our last video lecture until Thanksgiving break. So your next video lecture will not be until after Thanksgiving break. I'm so sad. You guys are probably happy. Anyway, today should be a pretty brief, well, one problem's going to be kind of long, but should be pretty quick, just 2 examples, and then we will kind of move forward here. So, really, it's going to be applications of what we've been working on. That's kind of a closeout of the chapter. I'm going to look at 2 word problems. The first word problem is actually going to be pretty straightforward. I think you guys can actually probably do without me teaching you. So I would challenge you guys on the first word problem to go ahead and work ahead. And actually, I would like you to do this problem as I do it on your checkpoint, please. Do not do it in your notes. Do this problem as your checkpoint as I do it. Okay, so you should be using your green paper for it. All right. Oops, not that. I'm going to do this problem first. We're looking at video game sales. From 1995 to 2003, the annual sales, S, in billions of dollars of entertainment software can be modeled by. Pick those problem out for those people who actually were up until midnight getting their new PS4 last night. Video game sales. ST is equal to 848 times T squared plus 3,220 divided by 115 T squared plus 1,000. Where T is the total number of years since 1995. T is the total of years since 1995. For what, now the question becomes, for which year were the total sales of entertainment software about $5.3 billion? So, again, this is since 1995. We want to know which year were video game sales or entertainment software a $5.3 billion industry. So that's what we're looking for. Hopefully, in the context of this problem, you're realizing that they want us to solve for T, and they've given us the answer. In this case, they've given us the answer in billions of dollars. So if my equation is F sub T equals 848 T squared plus 3,220 over 115 T squared plus 1,000. In this problem, they've given me the output of the function. 5.3 is the sales. And now I need to solve this equation for T in order to figure out how many years since 1995 this was a $5.3 billion industry. So really, this is a calculator crunch problem. Get your calculator out for it because you're going to be using it for most of the problem. And then we're going to go from here. So calculator crunch, solve for T squared, or actually solve for T. First thing we need to do is we need to get rid of the denominator there, which is 115 T squared plus 1,000. The way to get rid of the denominator is, if you want to think about it this way, I have a fraction equal to a fraction. Multiply both sides of this equation by its common denominator. Common denominator here will be 115 T squared plus 1,000. Multiply this side by 115 T squared plus 1,000. On the left-hand side, nothing will drop, so I'm going to have 5.3 times 115 T squared plus 1,000. I'm going to distribute that 5.3 to both terms. When I distribute that 5.3 to both terms, that will give me, let's see, 609.5 T squared plus 5.3 times 1,000 is 5,300. So that is the left-hand side. The right-hand side, as I multiply, my denominators will drop, and that's going to give me 848 T squared plus 3,220. So 609.5 t squared plus 5,300 equals 848 t squared plus 3,200. Now I really just need to solve this equation for t. I'm going to actually move my t's over to the right-hand side. The reason I'm going to move them over to the right-hand side is it'll keep my t's positive that way. So I'm going to minus 609.5 t squared from both sides. I'm also going to minus 3,220 from both sides. When I do that, my t-squareds will drop. 5,300 minus 3,220 gets me to 2,080. And again, calculator crunching there. On the right-hand side, my 3,220's drop. I've got 848 t squared minus 609.5 t squared. That will simplify to 238.5 t squared. Again, we're solving for t here. Divide both sides by 238.5. Divide both sides by 238.5. We've got t squared equals 2,080 divided by 238.5. Comes out to be, this is a decimal, and it comes out to be about 8.72-ish. That's just calculator rounding there. And now I need to square root both sides. And when we as a mathematician introduce the square root, we will put the plus or minus on there. And t will equal plus or minus. We take the square root of 8.72 in our calc, and I think we get like 2.95 there. So t equals plus or minus 2.95 in the context of this problem. T equals plus or minus 2.95. Going back to the original context, which year were the total number of sales of entertainment software about 5.3? Well, I actually have an answer of plus or minus 2.95. We're approximating, this is years since 1995, so my negative answer is not any good. It's also outside of my domain, so I won't use negative 2.95. I will use positive 2.95. I'm going to round that to 3. So if I round that to 3, 2.95, it says for which year were total sales of entertainment software about 5.3? In about 3 years. Specifically, in about 3 years since 1995. So in other words, in about 1998 was when there was $5.3 billion in sales. In video game sales. Okay? So there is the context of that problem, top to bottom. You should have done this problem on your checkpoint on your green, blue paper, sorry, not green, blue paper. Okay? That's it for that problem. Substitute in and simplify. Next up, no checkpoint. I want you to actually do this in place of your checkpoint. We're going to do this one together, so this should be on your checkpoint, blue notes. An alloy is formed by mixing 2 or more metals. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. Jewelry silver is composed of 80% silver and 20% copper by weight. How much pure silver should you mix with 15 ounces of jewelry silver to make sterling silver? This problem is kind of a pain in the butt. The math is the easy part. I need you to kind of set up what's happening here. Or I want to try to set up kind of something that makes sense, hopefully. We're starting with, and I'm going to abbreviate it as jewelry silver. I'll even just write it out. Jewelry silver and jewelry silver kind of is made up, and it tells us in the problem, 80% silver, and 20% copper. So I'm going to say 80% silver and 20% copper. That's silver and copper. And we have 15 ounces of that. So I'm going to write 15 ounces. We have 15 ounces of jewelry silver. And what we're going to do is we're actually going to take that jewelry silver and we're going to make what's the other one? Sterling silver. And the catch is sterling silver, its distribution is 92.5% silver and 7.5% copper. So here's the connection, or here's kind of what needs to happen. I've got the jewelry silver, and what happens is they melt it all together. It's 80% silver, 20% copper, and then they let it harden. And so I've got 15 ounces of that jewelry silver. What I want to do is turn the jewelry silver into sterling silver. The catch is 80% silver, 20% copper. I need to make it 92.5% silver and 7.5% copper. So it should make sense to you right now when I say we actually have to add silver to the jewelry silver. So jewelry silver plus more silver will get me to my sterling silver. Okay? So that's really what needs to happen, because I got to go from 80-20 to, if I add more silver to it, it'll get me to 92.5% silver and 7.5% copper. So my question is, how much silver do I need to add to turn it from jewelry silver into sterling silver when I have 15 ounces of jewelry silver? By the way, today's password code word, since I'm talking about silver so much, we will make it the Silver Surfer. Today's password is the Silver Surfer. All right. Getting back to the problem, I think I've kind of laid out the context of the problem for you, so it should make sense what we're looking for. In fact, I'm going to define my variable now. I want let x equal the amount of silver added. By the way, that's what we're looking for anyway. So x is the amount of silver added. Should also make sense to you that we're going to have to come up with some sort of equation. Okay? And here's kind of how that equation is going to work. I want my answer to be how much silver I added, but really what I want to look at is this. If I want to figure out my percent copper, how much of my mixture is copper? It should make sense to you that my percent copper will be the amount of copper divided by my total amount. Percent copper is the amount of copper divided by my total amount. Well, that should make sense. Okay? Well, where can we go from here? Copper percent. That's where I want to be at the end of this problem. Copper percent, at the end of this problem, I want it to be 7.5% copper. So when I'm transforming my jewelry silver into sterling silver, I'm adding that silver with it, I want to end up with my copper at 7.5%. 7.5% written as a fraction is 7.5 over 100. So that's where I want it up. Percent copper, it says sterling silver is 7.5% copper. Okay. How much copper do I have? I have 15 ounces, it's a little box there, a little bag, 15 ounces of jewelry silver. Of my jewelry silver, 20% of it is copper. So again, 20% of my 15 ounces, that should be some key words there, 20% of 15, 20% of 15 ounces is my percent copper, or the amount of copper I had. So my amount of copper is going to be 20% of 15 ounces. 20% of 15, that is the amount of copper that I have. And I'm not adding any copper. I want to add silver. So the total amount of stuff that I have, is going to be my 15 ounces of jewelry silver. It's going to be my 15 ounces of jewelry silver and the amount of silver I added. Well, the amount of silver I added is X. And that's my equation. As I told you guys earlier, the equation's kind of easy to solve, but once we get there, coming up with that equation is pretty hard. Okay? I'll admit that. That's kind of a hard equation there. So that's why I thought it was important to kind of set up the context to show you where I'm getting these things from, because that's where we're going to go. And I will expect you to be able to do this on today's assignment in class. So there's our equation. Now we're going to solve it. 7.5 over 100 equals 0.2 times 15 over 15 plus x. For us, this is the way I approached it in class. I'm going to multiply both sides by the common denominator. Common denominator is 115 plus x. 115 plus x. 115 plus x. On the left-hand side, my hundreds will drop, and I have 7.5 times 15 plus x. On the right-hand side, my 15 plus x's will drop, and I'm going to have 0.2 times 15. 0.2 times 15 is 3 times 100. 0.2 times 15, you could use your calc, it's going to be 3. Now I just need to solve my equation. I'll distribute that 7.5 to the 15. 7.5 times 15 is 112.5. 7.5 times x is 7.5x. 3 times 100 we can do, that's 300. Still solving for x, going to minus 112.5 on both sides. And that's going to give us 7.5x equals 300 minus 112.5, which is 187.5. One step left. Divide both sides by 7.5. And x is going to equal that. Oh me, oh my, I am shocked to see. Comes out to be a nice number, almost like it was supposed to. So in this problem, we actually have to add 25 ounces of silver, pure silver. So if I take 15 ounces of jewelry silver, melt it with 25 ounces of pure silver, I will end up with sterling silver, which is actually going to be almost 40 ounces of sterling silver. Okay? 25 ounces is what I need to add. That's it. You guys actually don't have any checkpoints today. All I wanted to do was these two word problems. So these two word problems should be in your checkpoints. There is no checkpoints. That is it for notes today. We'll start preparing for the exam in class tomorrow, and we will also have about 4 word problems that I'll expect you to be able to do. They are very similar to this. All right, that's it. Have a good night and good luck.